Hello everyone. So in this video I'll be going through using differentiation to find the turning points of a curve. So as you can see, this question in total is worth 9 marks, which is quite a lot. So it's really important to make sure that you're familiar with the process of working out the turning points. So this first part of the question, we see that they've given us a curve with this equation, and we're asked to find the coordinates of the two turning points. So turning point is a key word that whenever you see it on your paper, you should be thinking of differentiation. So what's differentiation? Well, it's the first derivative is, this is the notation of the first derivative, dy by dx. And the way we differentiate this equation right here is we take each term one by one and differentiate it. So let me just give the general process. If you have a term ax to the power of n, what you do is you take the power of n and you multiply it by a. So you take the power down and you get an, and then you keep the x the same. And then the power n, you reduce this power by 1. So it's an x to the power of n minus 1. So that's the general process of doing it. So now we do this for each term. So the first term is x cubed. So how would we differentiate this? Well, we take this power 3, multiply it here, bring the power down, so that becomes 3. Keep the x the same, 3x, and reduce the power of 3 by 1. So 3 minus 1 up here, which is 2. So 3x squared. So the first term is 3x squared. Now we do this for a second term, which is 8x squared. So the same thing here, we take this power of 2, multiply it by the 8, which is 16, and keep the x the same, and then reduce the power of 2 by 1, which is 2 minus 1, which is 1. So 16x to the power of 1, which is going to be rewritten as 16x. So plus 16x. And for the final one, 5x. Same thing, 5x can be written as 5x to the power of 1, since x to the power of 1 is just x. So we take this power of 1, multiply it by 5, we get 5. And now we take this power of 1 up here, we keep the x the same, we write this here, 5x. And now we take the power of 1 up here, and we reduce it by 1, which is 0. So we get 5x to the power of 0. But we know that x to the power of 0 is equal to 1, because anything to the power of 0 is equal to 1. So therefore 5x to the power of 0 can just be rewritten as 5. So therefore the final term of this is plus 5. So now that we have dy by dx, we can start by trying to find out the turning points. Well, firstly, we need to know what dy by dx exactly is. It's just the gradient function, which allows you to calculate the gradient at a certain point. However, in this case, we're asked to find the coordinates of the turning points. And the turning point is when the gradient is equal to 0. So let me just illustrate this visually on a graph. So suppose we have this curve that looks like this. The turning points will be the 2 points where the gradient is 0, the tangent to the point. So it would be these 2 points right here. Because if you drew a tangent to those 2 points, like so, you would get a gradient of 0. This is just a horizontal line, so that's a turning point. That gradient is equal to 0. So therefore, at these 2 points, dy by dx is equal to 0. So now we can see that if we want to find the turning points, we have to find the 2 points where dy by dx is equal to 0. So all we do is we equate this to 0. And an important phrase to write down in the exam is that turning points occur when dy by dx is equal to 0. This is important to remember. Turning points occur when dy by dx is equal to 0. So now we just set this equal to 0. 3x squared plus 16x plus 5 equal to 0. And now this is a quadratic which we can solve. We can either solve it using the quadratic formula, or we can factorize it like so. And if you multiply out this, you'll see that it's exactly the same up here. So it's been factorized, fully factorized. And this is equal to 0. So now we know that either this is equal to 0 or this is equal to 0 in order for their products to be 0. So therefore we get 3x plus 1 is equal to 0, or x plus 5 is equal to 0. So in this first case, we get 3x is equal to negative 1. Therefore, x is equal to negative 1 over 3. And in the second part here, we get x is equal to negative 5. So now we have the two x coordinates of the two turning points, respectively. So all we have to do now is take the original equation, y equals x cubed plus 8x squared plus 5x. Let's write that here. And now all we have to do to find the y coordinate is to substitute in these x coordinates. So if we start with negative 1 over 3, we get y is equal to negative 1 over 3 cubed plus 8 multiplied by 1 over 3 squared plus 5 multiplied by negative 1 over 3. And then if you evaluate this, putting into the calculator, you'll get that y is equal to negative 22 over 27. So therefore, now we have found the first coordinate pair. X is equal to negative 1/3 and y is equal to negative 22 over 27. That's the first turning point that we found. So we can put that in as our first answer. Negative 1 over 3 and negative 22 over 27. That's the respective y coordinate for the x coordinate. So now we do the same here for this x equals to negative 5. We put the original equation of the curve y, which is y equals 8x cubed plus 8x squared plus 5x. So if we write that here, now all we have to do is substitute in this x value, negative 5. So we see that y is equal to negative 5 cubed plus 8 multiplied by negative 5 squared plus 5 multiplied by negative 5. And after you put this into your calculator, you'll see that you get a y value of 50. So therefore, we have found the second coordinate pair of the second turning point, negative 5 and 50. Therefore, the coordinates of the other turning point, the second turning point, is negative 5, 50. So that's the first question done. Now, the second part of the question asks us to find the nature of the turning points. And by nature of the turning points, that refers to whether each of the turning points is a maximum or a minimum. And what a maximum means is that, let's go back to this graph right here. We see that this point right here, point A, let's call this A, and this point right here, point B. Of these two, we see that A is a maximum point because it's the maximum point the graph reaches. And B is the minimum point. It's the local minimum. It's the minimum point of the graph. And for the sake of IGCSE, we don't have to worry about these two here going off to infinity and negative infinity, which is why A is a maximum, the local maximum it's called. And so it may not seem like it's the maximum since this graph extends upwards infinitely, and so does it here downwards, which is why we refer to it as the local maximum. But for IGCSE, they'll just call it the maximum point. So we see that A is the local maximum point, and B is the local minimum point. So that's what they're asking us to find. We have to see whether each of these two turning points is a maximum or minimum. We're trying to find out that out. So the way to find out whether a turning point is a maximum or minimum is we use the second derivative, which is d2y by dx squared. So to find the second derivative, all we have to do is differentiate dy by dx, the first derivative. So we know that dy by dx is equal to 3x squared plus 16x plus 5. So to find the second derivative, d2y by dx squared, we do the same process up here of finding the derivative. Where you multiply the power, bring the power down, multiply it. So for this first term, it's 2 multiplied by 3, which gives us 6, and then we keep the x the same. And then we reduce the power up at the top by 1, so that power becomes 1, 2 minus 1. For the second term, 16x can be rewritten as 16x to the power of 1. So we take this power of 1 multiplied by 16, which gives us 16, and reduce the power by 1, so x to the power of 1 minus 1, which is x to the power of 0. But we know that x to the power of 0 is 1. So therefore, this is just 16 times 1. And for the final term, we have 5. And 5 can be rewritten as 5 multiplied by x to the power of 0. Because we know that x to the power of 0 is 1, so it's the same thing. So we can just do the same rule here. We take the power of 0 multiplied by 5. And we get 0, and then keep the x the same. And then reduce the power by 1. So 0x to the power of negative 1. But we know that anything multiplied by 0 is just 0. So therefore, we don't have to, it just becomes plus 0. And we don't have to worry about that as part of the final second derivative. So therefore, d2y by dx squared is equal to 6x to the power of 1. It's the same as 6x plus 16. And we don't have to write down plus 0. So now we found out that d2y over dx squared, the second derivative, is defined by 6x plus 16. So how would we use this to find whether each point is a maximum or minimum? Well, this is a key thing for IGCSE. This is a key point you need to know, and I'll illustrate this shortly. But we need to know that if after substituting in these x values into the second derivative, if the resulting value is greater than 0, then it is a minimum point. And if the result is less than 0, then it is a maximum point, the point. So these are two rules you need to know for IGCSE. And there's also an interesting case where the second derivative is equal to 0, which you do not need to know for IGCSE. But it is quite interesting, and it's called an inflection point, which you don't necessarily need to know for IGCSE. But these are the two main ones that we'll be working with for the questions. And so now all we do is we take each of the x coordinates, which is -1/3 and -5, and all we do is substitute it into d2y by dx squared. So therefore, when x is -1/3, the first turning point, we have if we substitute in this x value into this right here for d2y by dx squared, we see that x is equal to -2 plus 14, plus 16, which is equal to 14. So d2y by dx squared is equal to 14 for the this turning point, when x is -1/3. And since it's greater than 0, from this rule we know that it's a minimum point. Therefore, -1/3, which is the x coordinate, we also need to know the y coordinate. This is the point. We have calculated this up here. So this point right here, this is the first turning point that we have calculated up here. The first one that we had is a minimum point, since d2y by dx squared is greater than 0. So now if we do the same process for x equals to -5, substitute in the value into the second derivative, we get an answer of -14. So d2y by dx squared is equal to -14. So therefore, by this rule here, it's less than 0, it's -14, therefore it's a maximum point. It must be a maximum point. So therefore, this turning point with x coordinate at -5, which is -550, is a maximum point. So yeah, that's how you solve this question. And now I'm just going to be briefly going on to illustrate this example right here. This like proof why it works, because many students just have remembered it without really understanding what's behind it. So here we've seen that if the second derivative is greater than 0, then it's a minimum point. So to illustrate this, let's say we have point C here and point D over here. So as you can see, C has a negative gradient, whereas D has a positive gradient. So as you can see, between C and D, the gradient is rising. It's continually rising. It's going from a negative gradient at C to a positive gradient at D. And since B lies between C and D, it must be the case that this second derivative is greater than 0, since it's causing a rise in the gradients. The gradient is going from negative to positive. So therefore d2y by dx squared, is greater than 0 for this area of the graph where B lies in. Therefore B is the minimum point. So that's how you know that if the second derivative is greater than 0, then the point must be a minimum. So similarly, if we have a point E here and a point F over here, if we draw the gradient of the tangent at E and then the same at F, we see that E has a positive gradient and F has a negative gradient. Therefore, between the region E to F, the gradient is decreasing. It's going from positive over here to negative, since E has a positive and F has a negative. So the gradient is decreasing. Therefore, d2y by dx squared is negative. It's causing the gradients to decrease. It's going from positive to negative. And since A lies between this region here, between E and F, d2y by dx squared must be less than 0 for A. But we can see on the graph that it's a maximum point. A is a maximum point. So we see that this is the proof of when the second derivative is greater than 0, we have B, a minimum point. And when the second derivative is less than 0, we have A, this maximum point. But yeah, you don't really need to know that for an IGCSE course. I just thought it would be helpful in making you understand why we have this formula right here. And yeah, that's it. All you need to know for differentiation and turning points for IGCSE maths. If you have any questions, please let me know in the comments. And if this video is helpful, please like, share, subscribe. Thank you very much.